The year was 1996, the year I graduated from high school, and like every other Texas high school graduate in 1996, we applied for colleges and hoped we'd get into wherever we applied. While I was in the top 10% of my class, I still had to apply. So fast forward 1 year, where Texas House Bill 588, or commonly known as the Top 10% Rule, passed in 1997, it was signed into then-Governor George W. Bush that guaranteed Texas students graduating in the top 10% of their high school class automatic admission to state-funded universities. And unfortunately for me, this came a year or so late and created a little extra stress on waiting to see admission status. But all is well that ends well, right? Or is it? In this presentation, I will review a study by New and Tienda titled The Impact of the Texas Top 10% Law on College Enrollment, a Regression Discontinuity Approach. It was published in 2009 in the Journal of Policy Analysis and Management. I'll first review the research design of regression discontinuity, followed by a discussion of New and Tienda's research questions, the data sets utilized, the study measures, the study methods, the results, and end with the discussion of my interpretation of the study and the research design. First, let's review the research design of regression discontinuity, which is a quasi-experimental pre-test, post-test, or pre-post treatment design that's really aimed to determine causal effects of interventions through an assigned cutoff point or threshold above or below that of an intervention. So then one compares the observations that lie close to either side above or below this cutoff point to estimate the average treatment effect in situations or environments where randomization is not possible or feasible. So with regression discontinuity, one cannot make true causal inference alone because the method does not automatically reject causal effects by potential confounding variables. Regression discontinuities, in a way, remove secular trends and can either be a natural experiment or initiated by a researcher. And there are 3 types of regression discontinuities. A sharp regression discontinuity is clear cut points that is used to assign a treatment based on continuous forcing variables. In this case, observations are compliant. Spatialarity refers to some border cut points, and then fuzzy regression discontinuity is used when compliance with the treatment is not 100% on forcing variables. The assumptions associated with the regression discontinuities design include the following. The relevant variables beside the treatment and outcome variables must be continuous at the point where the treatment and outcome discontinuities occur. Trends are similar before and after the cut point, that's an assumption, and the cut point must be exogenous or arbitrary, random as can be, and observations have no way of moving themselves before or after some cut point. To implement regression discontinuities, here's a general overview of the steps. You find a random sample or population. You identify where the participants fall on the forcing variable, right? Where's that cut point? You organize participants by the values on that forcing variable, determine the cut point arbitrarily on a covariate to split the sample at that point, assign participants on one side or the other of the threshold for the treatment, right? And then implement and view the treatment effect in the assigned group, measure the outcomes for everyone, and run the analysis. Some checks or tests for validity of the assumptions and regression discontinuities include density tests, continuity of observable variables, falsification tests such as sensitivity, balance checks, placebo thresholds, sorting or continuity in the predetermined variables, and then inclusion and exclusion of covariates. Advantages of regression discontinuities include that it yields unbiased estimates of a local treatment effect when correctly implemented and analyzed. Regression discontinuities can almost be as good as a randomized experiment in measuring a treatment effect. Because regression discontinuities is quasi-experimental, ex-ante randomization is not required, which avoids ethical issues, right, of random assignment. And then a well-ran regression discontinuity studies can generate treatment effects estimates that are comparable, again, to those from randomized studies. Some disadvantages of regression discontinuities include that the estimated effects are unbiased only if the functional form of the relationship between the treatment and outcome is correctly modeled. Non-linear relationships can be mistaken as discontinuity. And there can also be contamination by other treatments. So, for example, if a treatment has the same cutoff point of the same assignment variable, the measured discontinuity in the outcome variable may be partially attributed to the other treatment. When random assignment studies are not possible, either due to circumstance, ethical considerations, or other factors, for example, a reluctance to deny those with greatest need some intervention or policy change, regression discontinuities is an approach that allows researchers to estimate the intervention, policy, or program impacts in situations where participants are selected for treatment based on whether their value is higher or lower than the designated cut point. Thus, by correctly controlling for the value of the rating variable in the regression equation, the researcher can account for any unobserved differences between the treatment and comparison groups, which are separated by the cut point, and some of the estimation issues that wouldn't necessarily be picked up with the OLS as accounting for unobservable factors. And so to summarize, regression discontinuities is used when random assignment is not possible, participants cannot manipulate the assignment variables, the cut points might already be in place. It compares this assigned with the treatment with a control group, provides a way to remove secular trends, and has strong internal validity. The No and Tienda study examined the following 3 primary research questions. 1. How did the impact of the top 10% law differ for Hispanic, Black, Asian, and white students? And the sub-question there is, were the increases in minority college enrollment into flagship Texas universities after the top 10% law was implemented attributable to the new top 10% rule, or due to changing population composition? Question number 2, did the impact of the top 10% law on flagship enrollment rates differ by ethno-racial composition of high schools? And then 3, did the impact of the top 10% rule on enrollment at the flagship campuses differ from students from Longhorn and Century high schools? And those were rank-eligible graduates from 2 low college-going tradition schools that had high shares of economically disadvantaged students, and they were offered tuition scholarships to attend their respective institutions. So, No and Tienda's hypothesis was that the top 10% law impacts flagship enrollment among top-performing underrepresented minority students and graduates from minority high schools and from resource-poor high schools. No and Tienda used data from the senior cohort of the Texas Higher Education Opportunity Project survey data, which is a representative longitudinal study of Texas public high school students that were first surveyed during spring of 2002 using a paper and pencil and class survey instrument. And that data set had 13,803 respondents. And then due to cost, the researchers in this study used a random subsample of the baseline respondents with an N of 5,836. And researchers re-interviewed respondents by phone 1 year following high school graduation. The researchers also used administrative data from the Texas Education Agency, or TEA, on ethno-racial composition and socioeconomic heterogeneity of Texas public high schools. Data characteristics included proportional samples of respondents by ethnicity for some and random selection from the cohort data for others. So to address representation and generalizability, baseline respondents who were Black or Asian were included in the longitudinal sample, and then proportionate samples of Hispanics and non-Hispanic whites were randomly selected for the sample balance. And response rate for the Wave 2 interviews was about 70%. Sample weights for the follow-up interviews were recalibrated to the original population. The baseline survey collected the following information: basic demographics, socioeconomic data, standard tracking information, self-reported information about grades, decile class rank, and future plans. The Wave 2 follow-up survey recorded college enrollment 1 year post-high school and university of enrollment. Researchers validated the class rank, they standardized test scores, and high school GPA via a transcript verification procedure conducted by high school administrators and staff or respondents interviewed in the Wave 2, which yielded about verification of 86% of records. The transcript-based class rank is precisely measured, which is necessary for regression discontinuity. The dependent variable, or outcome of interest in this study, was attendance at one of 2 Texas flagship universities, University of Texas Austin, UT, or Texas A&M University, TAMU. The treatment variable is automatic admission into Texas public universities. The cut point variable was the top 10th percentile rank, or the decile, in high school graduating class. The independent variables included ethnicity, underrepresented high schools, ethno-racial composition of schools, socioeconomic heterogeneity of schools, social economic status, school, college-going traditions, and then other control variables included family, socioeconomic status variables such as parental education and home ownership, respondents' college disposition, the grade level when the respondent first considered college, and standardized test information such as test scores, and dummy indexing variables were used if the test was not taken. So as mentioned previously, the authors used transcript-verified class rank information, continuous variables, and the regression discontinuities technique because this method allowed for a comparison group whose admission did not factor in the top 10% law, thus allowing for causal inferences. So they specifically selected regression discontinuities because previous studies used survey data with a lack of comparison group, self-reported data, and approximate post-secondary outcomes. Further, the research selected and stratified the respondents by these factors because legislators created the top 10% law to broaden access to selective public institutions for students from underrepresented high school and demographic groups, hence stratification by the different groups. The 5 economic strata included affluent high schools with low shares of economically disadvantaged students, feeder high schools, which were affluent schools with strong traditions of sending students to A&M and Texas A&M and UT. Poor high schools were high shares of economically disadvantaged students. The Longhorn Century schools were poor high schools with low college-going traditions targeted for outreach and scholarship by UT and A&M, and then typical high schools, which had average shares of economically disadvantaged students. The strata for the ethno-racial composition used percent white as the baseline referent and had 5 categories. So predominantly was more than 80% white, a majority was 60 to 80% white, integrated was 40 to 60% white, a majority minority was 20 to 40% white, a predominantly minority school was less than 20% white. The authors point out that the high school segregation and economic indicators represent very substantially different constructs, although there is some overlap and they do provide examples to support their claim. So the article did not include the baseline model, but shown here is a standard OLS model and what that might look like. So then the study applied an RD or regression discontinuities design that has this equation. A general RD design is shown first, right? And then you have the sharp RD design, which was used by the study. And this is the one that they included in the article, and where you have the Y, you have that there. And then, of course, the outcome was student enrollment. What was interesting about this, it was a binary yes, no. So 0, no, 1, yes, they attended a flagship school. And then the G value was this rank or continuous function of high school percentile class rank. Your T was the top 10% status indicator function, and T was the control group. The top decile students were in the control group, and then T equals 1 was the treatment group. The Z was the vectors of individual characteristics that affected college enrollment outcomes, and then the other value is estimate differences observed from implementing programs given certain levels of non-participation intent to treat the effect, the ITT value, and then you have your error term. And the regression discontinuities model used a probit specification, which means that the dependent variable, as I just mentioned, it has only 2 options for values, right? The outcome. In this case, it was they attended the flagship university or not, and you have the model there. So the flagship enrollment is assumed to be a continuous function of high school percentile class rank, and they estimated local linear regressions with simple rectangular kernel and verified robustness the results to bandwidth choices. So the authors shrunk the bandwidth, starting with 10 percentage points on either side of cut points to 4 percentage points around the cut point. The authors stated that they used the regression discontinuity design because the design allowed for a control and treatment group with an existing cut point, allowing for a sharp RD design. And the top 10% rule, which they cited, were limitations of the previous research. So rank is a continuous function of actual high school percentile, and enrollment is a continuous function of high school percentile rank. So previous research and limitations, this design, the RD design, could potentially address. The authors used a regression discontinuities design. They also used a probit specification because the outcome had only 2 options, attend a flagship university or not, assuming the error term was distributed normally, which gave them the estimated marginal intent to treat effect of the 10% law on students' college enrollment. And given the estimated impact only applies to students near the cut point, the impact of the law on students far from the cut point may be very different. So the authors estimated local linear regressions with simple rectangular kernel and verified the robustness of results again with different bandwidths to reduce bias from over or under selection. The researchers ran descriptive statistics for the top decile students, and those ranked at or below the 10th percentile verified the researchers' basic assumption of the RD design. Flagship enrollment means are significantly different between those above and below the cut point. The narrower intervals round a cut point of 3 to 10% versus 11 to 18%, and also 7 to 10% versus 11 to 14%. There were significant differences in flagship enrollment that persisted for students ranked above and below the 10% rank. Most differences in covariates were not statistically significant, except for Asian origin, parents with less than high school education, college entrance exams taken, and test scores. When the class rank interval narrowed to 2 points on either side, differences in flagship enrollment remained statistically significant with a p-value of 0.02. So findings suggest that the top 10% law did not affect the likelihood of enrollment at flagship universities when conducted for everyone, right? For all the seniors. The top 10% law appears to impact flagship enrollment for Hispanics and not some of the other groups. So flagship enrollment decisions for students from predominantly white high schools was not affected by the top 10% law. However, graduates from predominantly minority high schools had a clear discontinuity at the cut point with sizable probate estimates that were statistically significant. The class rank cut point for seniors from schools with 80% or more minority students are 14 percentage points more likely to enroll at UT or Texas A&M than their classmates that were ranked immediately below the cut point. The top 10% roles affected flagship enrollment among students who graduated from high schools with average shares of economically disadvantaged students. And so the authors state they have established evidence of discontinuity at the 10% class rank. The cut point for the three subgroups included students who were Hispanic, students from predominantly minority high schools, and students from high schools with average shares of economically disadvantaged students. So they also stated that for students near the cut point, the apparent disjunction could have two explanations or interpretations. So for example, either the top 10% law boosts flagship enrollment probability for those that are ranked immediately above the cutoff point, and or the top 10% law dampens flagship enrollment probability for those that are ranked immediately below the cut point, right? So you could look at it either way. And a limitation that the authors point out is that the survey data didn't allow them to ascertain the relative weights and whether or not both mechanisms could operate. However, the authors do state that the findings from other studies using administrative data suggest that the observed discontinuity largely reflects the boosting effect of the top 10% law on flagship enrollment among rank eligible students. This study chose the RD method because of limitations of the previous study. So the authors conducted previous results with other methods where they used survey data and no control groups. And the authors also cited a study belonging to TND in 2008 that used a natural experiment by using Texas University administrative data to look at the changes in admission and enrollment probabilities. And they concluded the top 10% plan is an ineffective proxy for race-sensitive criteria. Another study said, Coffin and TND in 2008, said that graduates from affluent schools are the major beneficiaries of the top 10% law because graduates from those schools are significantly more likely to apply to public flagships compared to graduates of high schools serving students of low to moderate socioeconomic status. So the authors then cite limitations in these studies using administrative records because records alone can't consider the range of alternatives that students consider in college attendance decisions. So they chose the regression discontinuities designs which they felt provided a more robust results. And they used the existing cut point, and the results supported some of the findings and expanded and clarified findings from other studies because the study they did used verified rank information instead of self-reported survey and administrative data as the previous studies utilized. So the authors explain in this study the steps taken in great detail that they took to reduce over or under estimates through robustness checks, such as changing the bandwidths. The authors sought to examine the effect of treatment, the automatic admission to a Texas public university, and increased flagship enrollment among Hispanics and those from predominantly minority high schools. The RD design result provided the evidence of that effect of treatment. The authors stated their surprise. They also found strong evidence that the top 10% law benefits graduates from typical high schools. So, in other words, this approach allowed them to find even additional findings than what they were expecting. So the authors believe that the regression discontinuity method was useful in estimating effects and providing substantial analysis and data sets to test for the robustness of the various models, which they stated the results were robust to alternative specifications and bandwidth choices around the cut point. The authors provide evidence to support their claims that comparisons of flagship enrollment between students at the cut point and those below indicate the top 10% law impacts the likelihood of flagship enrollments for students who are Hispanic. Students graduating from predominantly minority high schools and enrollment among students graduating from typical high schools, many of which have weak traditions for sending students to the flagship universities. So they provide strong evidence of the robustness of results to alternative specifications and bandwidth choices around the cut point. And I agree with the authors that their regression discontinuities results appear consistent with the intent of the top 10% law, which is to restore ethno-racial and socioeconomic diversity at public flagships and to increase college access. So the article clearly addressed their provision of evidence and robustness to support causal inference for the three populations mentioned, and the authors acknowledge that their application of the RD approach can't compare the effectiveness of the top 10% law and affirmative action as a diversification method for college campuses. The authors are clear to point out that the success of the RD design in providing evidence of causality depends on how well the variables are specified. Estimates will be biased or inefficient with misspecified variables, and overspecified models are unbiased but inefficient, and then underspecified models are both. So in order for regression and discontinuity designs to address causality, the functional form is critical. Researchers can estimate the model separately with second-order and fourth-order polynomial terms for the variables of interest and report both sets of results to determine whether estimates are or are not sensitive to model specification. And when conceptualized and run correctly, the regression discontinuity model has the potential to produce evidence of causality that is comparable to randomized studies, as researchers can use RD designs when random assignment is not possible and it provides strong internal validity. The references for this presentation are shown in the next few slides. Please feel free to reach out if you have questions. I look forward to your feedback and questions. Thank you.